We'll proceed in Fibonacci series with integral calculus. Fibonacci series with integral calculus. This is what the discussion we are pursuing. We will try to have two things. One is how to deduce Fibonacci series. Partially we have talked earlier. We will talk more on it. How to deduce Fibonacci series. There are many ways I am seeing how to deduce Fibonacci series, but whatever we had talked earlier on deducing the Fibonacci series, we will go with that only and we will complete it. It looks like it is promising one. How to prove Fibonacci series base? What is the algebraic equation of a Fibonacci series? Fibonacci series, people understand what is Fibonacci series? If I have one amoeba, newborn amoeba in my hand, and then newborn amoeba will take 2 days to come to a maturity level where on daily basis it will start multiplying into 2. If amoeba can divide into 2 on its own, so a baby amoeba, if it is in my hand, baby amoeba it is in my hand, then baby amoeba will become a mother amoeba after 2 days. Today, tomorrow, it will take time to grow up, and day after tomorrow, it will divide it into 2. Then day after tomorrow, day after tomorrow, it will divide into 2 again, and so on. Okay, so what will be the number of amoeba on a particular day? That is the Fibonacci series. Today, one child amoeba, tomorrow one child amoeba, and third day is mother amoeba and child amoeba. So total amoeba is 2, 1, 1, 2. On fourth day, two child amoeba and one mother amoeba. On fifth day, two mother amoeba and two child amoeba. So two mother amoeba, two child amoeba and one child amoeba from the previous day. So we will start again. On the first day, I have a child amoeba. Second day, I have a child amoeba that is growing up. Third day, child amoeba has become a grown up amoeba and it is dividing into 2. Now we have child amoeba and mother amoeba. Makes sense? On fourth day, I have child amoeba. From the previous day, I have child amoeba and mother amoeba. On the previous day, I have child amoeba and mother amoeba. From previous to previous day, I have one child amoeba. Whatever there is on previous day, that will be there on the next day. First day, child amoeba. Second day, child amoeba. Third day, mother amoeba and child amoeba. Fourth day, if I talk about fourth day, then whatever is there on the third day, they will be available on the fourth day also as it is. So mother amoeba, child amoeba. 2 days prior on second day, whatever amoeba is there, it would have grown in the 2 days. So that will exactly replicate into the same number. So 2 days back we have one child amoeba. That will become one more. So whatever there on 2 days back, that count plus whatever there on one day back, that count if I add, then that becomes a 2 day count. If I want to calculate the count of amoeba today, then yesterday, what was the count of amoeba? Because they are going to become today also. They are not going to die. And yesterday, before yesterday, day before yesterday, whatever amoeba count was there, that amoeba, either it is a mother amoeba or child amoeba, intermediate amoeba, whatever it is, after 2 days, they are going to replicate. Day number 1, day number 2, day number 3. On third day, whatever the count of amoeba on second day, those amoeba will be present on third day. They are not going to die. And whatever the amoeba were available 2 days back, all amoeba, either it is mother, children, intermediate, all amoeba after 2 days, they are going to exactly replicate into the same number. If there are 5, then 5 will become 10 here. means 5 new will get added, whatever there on the previous day plus whatever there on the previous those this will become exactly double, and this is what it will come here. So on particular day number x, number of amoeba is on day number x minus 1 plus amoeba on x minus 2, because x minus 2 is going to double on after 2 days, and previous day they are anyway coming to the next day. This is called Fibonacci series. Function over x or number of amoeba on the xth day is same as number of amoeba on the previous day, x minus 1 day, plus number of amoeba on x minus 2 days. This is Fibonacci series. So if I have taken a baby amoeba, if I have taken a baby amoeba on day number 1, then Fibonacci series is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. Where any day amoeba count is same as last day amoeba count plus last to last day amoeba count, because last to last day amoeba would become double now. So it will add equal number on the after 2 days. So this is typically called Fibonacci series. How Fibonacci series can be deduced in terms of x? If I say I want to know the number of amoeba on day number x as function of x, I want to know the number of amoeba on day number x as function of over x. Means I would be able to say that amoeba on day number x is sin x plus log x plus e to the power x plus whatever. It should be in term of x. X should be independent variable. What we have got is fx function over x equal to function over x minus 1 plus function over x minus 2. What you want? I want function over x in term of x only, not function over x minus 1, function over x minus 2. This is what is seeked. This is what we want. Okay. If that is the scenario, if this is what we want, if that is the scenario, then how we can start our computation? How we can start our computation? Fx equal to fx minus 1 plus fx minus 2. Fx equal to fx minus 1 plus fx minus 2. This is what we know. Let's divide both sides by fx minus 1. Fx by fx minus 1 equal to fx minus 2 by fx minus 1. Makes sense? Function over x, number of amoeba on xth day by number of amoeba on x minus 1 day equal to 1 plus number of amoeba on x minus 2 days by number of amoeba on x minus 1 day. Fx equal to fx minus 1 plus fx minus 2. If I divide both sides by x minus, this is one thing that we will take. Other thing is we have already calculated that if I say fx equal to ux for simplicity, function over x or number of amoeba on x day is ux. Another representation, another notation. Function over x plus 1, sorry, function over x equal to ux. Okay. If that is the case, function over x equal to ux, if that is the case, then what is u1 whole square plus u2 whole square plus u3 whole square plus u4 whole square plus un whole square, where u1 is number of amoeba on day number 1, u2 is number of amoeba on day number 2, plus u1 square plus u2 square plus un square, where un is amoeba on day number 9, or fx at x equal to n. Okay, then we saw it is un into un plus 1, irrespective of n is odd number or even number. It is un plus 1. Another question is, what is u1 whole square minus u2 whole square plus u3 whole square minus u4 whole square? Okay, for all the odd days it is square, for all the even days it is square, but negative is there. What will be the solution? That is what the question is. u1 whole square minus u2 whole square plus u3 whole square minus u4 whole square plus u5 whole square minus u6 whole square, and so on up to plus up to up to plus minus whatever un whole square. Where n is odd, then it is plus un whole square. If n is even, then minus un whole square. That is the n. What is the solution to it? That is again under question mark, and that we will see. Anyway, first we will proceed on proving the Fibonacci series. So Fibonacci series algebraic equation. The Fibonacci series algebraic equation is fx equal to fx minus 1 plus fx minus 2. If I divide both sides, then it is fx by fx minus 1 equal to 1 plus fx minus 2 by fx minus 1. Hold on. This is what we are getting. Okay. There are many kind of differential equation. If I say fx by fx minus 1, then it can be considered in two ways. One is that what is the division of amoeba count on x day by amoeba count on x minus 1 day. What is the division? What do you mean by division? Division means per. Division means per. Per means I have a sack of orange and I have a sack of orange and I have a sack of tamarind. A sack full of orange and sack full of tamarind. Okay, if that is the case, then in orange I have n number of orange, and in tamarind sack I have m number of tamarind. M for monkey, and n for nation. Okay, then someone would ask, how many oranges are there per tamarind? That is the question. Per tamarind, how many oranges are there? What do you mean per tamarind? How many oranges are there? What I mean is that if I keep tamarind one by one, consider I am arranging tamarind in row manner. Tamarind, one tamarind, one tamarind, one tamarind, one tamarind, one tamarind, one tamarind. Similarly, I am arranging all the oranges in row manner. One, 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 one. But it is not it is n row will come. And here M or M row will come in tamarind. M tamarind are there. N orange is there. So certainly, if orange is more, then orange will grow in the row count where tamarind will over. If I arrange tamarind in row, first one tamarind, one tamarind, one tamarind, then last one will be MH tamarind, M for monkey. If I arrange orange in 1, 2, 3, 4, 5, 6, 7, 8, 9, N oranges. If N is more than M, orange row count will be same, will be bigger. No. I want same row count. Row count should be M only. Then you have to group few oranges in every row. Next. If I have m number of tamarind, there are row. Each row I have one tamarind, and mth tamarind row I have one tamarind. Okay, if I want all oranges to come in m row only, there are n number of oranges. If I want all oranges to come in m row only, like tamarind, then I have to group few oranges in every row. How many oranges are there in every row? Next, this is the division. So there are m number of row, m for monkey, and each row I have few set of oranges. So that if I distribute all the oranges, but in every row number of orange should be same. So if I arrange in that manner in the mth row, where one tamarind is there, number of orange should be over. This is how it is. Per row, how many oranges are there? This is called n by m. Per tamarind, how many oranges are there? This is called n by m. If I say fx by fx minus 1, fx by fx minus 1, then per x minus 1, per amoeba on previous day, how many amoeba I have on today? If today number of amoeba is fx, then previous day how many amoeba are there? If I divide, then per amoeba on the previous day, how many amoeba I have today? Makes sense? Someone can say per unit change in amoeba on previous day is how many unit change we see today. What do you mean? What do you mean? Okay, what I mean is very clear. If I have a bag, or sack of orange, if I have a bag of tamarind, If I have a bag of tamarind, I have a bag of orange. Tamarind, I have m number of tamarind, and in orange, I have n number of orange. Per tamarind is n by m oranges. What it means? It means that if I add one more tamarind in the tamarind sack, then I have to add n by m orange in the orange bag, so that ratio will be same. Makes sense? Okay. Now consider that at one time in tamarind bag, tamarind is 2, whereas in orange bag, the in orange bag, it is 4. Then what is the ratio? Per tamarind, there are 2 oranges. Makes sense. Next time when I am seeing in tamarind bag, there are 3 tamarind, then I know if there are 3 tamarind, then here it will be 6 oranges because n by m is 2. But when I am counting it, it is 9 oranges. When it is 2 tamarind, then it is 4 oranges. When it is 3 tamarind, then it is 9 oranges. When it is 4 tamarind, then it is 16 oranges. Then I am scratching my head now. What's going on? Okay, every time division is different. One time division is 2, next time division is 9 by 9 by, next time division is 9 by 3, that is 3. Next time division is 16 by 4, 4. What's going on? How I can estimate that next time if I put orange in the orange and tamarind in the tamarind bag, if I put, then how much orange I need to put in the orange bag so that it will be understandable. Here, rather than division, differentiation comes into the picture. Differentiation says that at any moment, what is m by n by m? What is orange by tamarind? Orange by tamarind is constant irrespective of how many tamarind and how many orange is there. This is called division. M by n is division. But every time when tamarind is changing, every time then n by m is different. This proves that something else is going on. This proves that per unit change in tamarind at any moment brings brings some change on orange at that moment, and that follows algebraic equation. It is not a constant. Okay, then it is called differentiation. Differentiation means division, but division is changing every moment. At particular moment, what is the division? What do you mean? If I say that if I have tamarind 2 and orange is 4, if I add one more tamarind, then change in tamarind is 1, and then change in orange is 4 to 9, 5. D orange by D tamarind, when tamarind count is 2, means orange by tamarind. This is called differentiation. At a particular moment, what is the division? Because division is not constant throughout the procedure. Every moment division n by m is different. A particular moment, what is the division? You tell me. That is differentiation. Okay, so someone would say that looks like dn by dm per unit change in tamarind, d orange by d tamarind, do by dt, do by dt. It looks like it is equal to 2x. Looks like. What do you mean by 2x? 2x means whatever the tamarind count is, it is getting doubled. I mean, if tamarind is 2 and then I'm adding 1, then what is tamarind count here? Tamarind count is 2 and I'm adding 1. At that moment, tamarind count is 2. Then I have to add 2 into x. Then I have to add 4, means I'm adding. If tamarind count is 3, then I have to add 2 into 3 here. That is 6. Anyway, I'm adding 7 plus 1. Makes sense? Okay, someone can say if you have 3 and you are adding more in between 3 and 4 is 3.5. That is double of it, that is 7 whatsoever. If I have a tamarind at any moment is x, then I am adding one more to tamarind. Then how much I need to add in the orange? Dy by dx. If dy by dx is 2x, means dy equal to 2x dx. Integration will be x square. Means at any moment, means anyone can understand. Okay, when tamarind count was 2, and orange count was 4. When I added 1, then here I added 5. Makes sense? When tamarind count is 3 and I added 1, then I added 7 here. Makes sense? When tamarind count is 4, when I added 1 here, I added 9 here. 16 to 25. Looks like double I am adding to what the tamarind is right now, more or less. Means d orange by d tamarind, change in orange per unit tamarind is equal to 2 into tamarind. What it is, whatever the tamarind at that time, do by dt equal to 2t. Change in orange per unit change in tamarind is same as 2 into tamarind, whatever tamarind is available at that time. Okay, makes sense? Or someone would say it is 2t minus 1. It is not 2t, it is 2t minus 1. 2t, 2t plus 1. It is 2t plus 1. If it is t is 2, then 2 into, then we have to add 2 into 2 plus 1, 5. If it is 2t is 4, then 4 into 2, 8, 9 I have to add. 2t plus 1. do by dt equal to 2t plus 1. Okay, then do equal to 2t plus 1 dt. Integration will be t square plus t. This is how it is. Anyway, this is called differentiation and differential equation. What is dy by dt in term of y and t, and we solve it and we get the actual formula, more or less. Okay, similar way we are getting into the differential into the Fibonacci series. This is typically called differential equation. dy by dt, do by dt, d orange by dt, or something like that. Okay, it can be do by dt, it can be d2o by dt square, double differentiation. It can be d3o by d3 square, d3o by dtq, d3o by dtq, d4o by dt4. Makes sense? If the number of variable is only one, if number of variable is two, then like like u, like there is a function called u and function is over x. If I say I have an orange, then it is function over tamarind, o equal to function over t. If I have a dual variable u equal to some function over x y, or we can say u x comma y, function over x and y, dual variable, then if I take differentiation, then it will be partial differentiation. Partial differentiation means keeping one variable constant, du by dx keeping y constant, du by dy keeping x constant. If it is a single variable, then du by dx, d2u by dx square, d3u by dx cube. If it is a multivariable, then du by dx, du by dy. Double differentiation will be d2u by dx square, dtu by dy square, d2u by dx dy. What is dtu by dx dy? du by dx, first calculate keeping y constant, and then again differentiate du by dx against dy. Differentiation of du by dx with dy is d2u by dx dy. This is written in that form also. These are called partial differentiation when number of variable is more than 1. Now we will go to Fibonacci series. I'm sorry. Now when I write a differential equation, like in terms of orange and tamarind, we wrote d orange by dt equal to 2t or 2t plus 1. This is what we see. Then I have to solve it, and then I have to find what is the equation of orange in terms of tamarind as an algebraic equation. Here also we will try to do same thing. Okay, we will try to do same thing. Means fx by fx minus 1 equal to 1 plus fx minus 2 by fx minus 1. Okay, someone can take it division, someone can take it as a differential equation. dfx by dfx minus 1 equal to 1 plus dfx minus 2 by dfx minus 1, or fx equal to fx minus 1 plus fx minus 2. These kind of differential equation are of two types primarily, or can be four types. One is called linear equation, one is called non-linear equation, one is called semi-linear, and one is called quasi-linear. Four types. Okay, all the linear equation what we are talking, it can be homogeneous, inhomogeneous. Homogeneous means I am saying du by dx equal to 0. U is a function over x. U is a function over x. Du by dx equal to 0. Means d of dx, d by dx of u equal to 0. If I rename d by dx as L, that is called linear operator or differential operator. D by dx is differential operator that is placed against u. So if I say d by dx as L, then L of u equal to 0. If right hand side it is 0, it is called homogeneous equation. If right hand side is non-zero, it is inhomogeneous equation. D by dx of u equal to function over something else, function over x, gx, another function over x. This is non-homogeneous equation. Okay, consider I have a differential equation, linear differential equation. Linear differential equation means there is a linear differential equation operator that is applied on u. If I say I have uxx plus uyy equal to 0, with double derivative of u with x and double derivative of u with y equal to 0, it is linear or not, then I can think about a differential operator as dt d2 by dx square plus d2 by dy square that I have to place against u. If I place against u, then it will be d2u by dx square plus dtu by dy square. Make sense? Okay, this is linear equation. Okay, what is non-linear equation? Consider one differential equation as uxx plus u into uyy equal to 0. Consider a differential equation ux plus uy equal to 0. Then I can have a differential operator at d by dx plus d by dy applied to u. Then it will be du by dx plus du by dy or ux plus uy. U bottom right as a subscript x. That is the first differentiation of u against x, partial differentiation, keeping y constant. Means this is if I have a differential equation and that can be brought up into a term called L into U equal to 0. First equal to 0 means homogeneous. L into U or L of U, if it happens, then it is linear equation. If I have ux plus u into uy equal to 0, it is a homogeneous equation. But it is not a linear equation. I cannot find any d by dx and d by dy. If I placed against u, then it will become ux plus u into uy, not because I multiply with u. I should not multiply with the u. Now it is non-linear equation. If I have a algebraic, if I have a differential equation that is linear homogeneous, then it can have many solutions. Differential equation can come into quadratic equation and there can be many solutions. Consider I have a solution of, for consider I have a dual derivative kind of scenario or I have a quadratic, that we will see. I have a quadratic equation of scenario. If I have a quadratic equation of scenario, then there can be two value of u. Consider I have ux plus uy. Ux, I have ux plus uy. Okay, this is what the differential equation is. Now consider equal to 0. Means I have a u as a function. If I differentiate with x keeping y constant plus if I differentiate with y keeping x constant equal to 0. Consider there are two solutions possible to it. There are two solutions that is possible to it. Okay, what are these two solutions? This solution can be u1, u2. What do you mean u1, u2, u3? Consider uxy equal to minus uxy equal to y by 1 plus x. Makes sense? I have a function uxy. There is a function with x and y. Consider it is z. That is a three-dimensional function. Uxy or function over xy. Uxy equal to z. If this is xy plane, I have xy. Against each xy, I have a z that is uxy. And that is y by 1 plus x. If I have a xy plane and if I have a x-axis and y-axis, against each x comma y, I have y by 1 plus x as the vertical. Makes sense? If x is 0 and y is 0, then vertical is 0. Makes sense? If y is 1 and x is 0, vertical is 1. When y is 1, x is 1, then vertical is 1 by 2. This is how the 3D surface is being drawn. Okay, what is ux? First differentiation keeping y constant. Y by 1 plus x du by dx will be minus y by 1 plus x whole square. Makes sense? Our differential equation is ux plus uy equal to 0. Is it equal to 0? Then what is u? This is the question. If I have du by dx plus du by dy equal to 0, what is u? I am saying u is y by 1 plus x. How you know? I saw in my dream that u is y plus 1 y by 1 plus x. You don't tell me it is wrong. Okay. Ux du by dx is minus y by 1 plus x whole square. You agree with it? Yeah, I agree with it. What is what is what is du by dy then it will be 1 by 1 plus x, 1 by 1 plus x. Okay, if I sum it minus y by 1 plus x whole square plus y by 1 plus x, y by, sorry, 1 by 1 by 1 by 1 plus x equal to 0. It will not happen 0. Okay, this proves that solution is wrong. Solution is wrong. Okay, someone can try and if I say my solution is 1, u equal to 1, then try. Okay, ux is 0, uy is 0, 0. Yeah, this is one of the solutions. So, what can be another solution? What can be another solution? Now, people can think what can be another solution to ux plus uy equal to 0. Okay, hope. Someone can try. Consider I get two solutions, u1 and u2. Okay, because ux plus uy is a linear homogeneous equation, that is for sure. Now I have to find u. First u is 1. There can be another u also. There can be another u also. Who knows? There can be multiple solutions to same problem. If I have u1 and u2 as problem, means if I got another solution as u2, then du2 by dx plus du2 by dy should be 0. If I got u1 as the first solution as 1, then du by dx plus du by dy, indeed it is 0. Then if it is like linear homogeneous equation is there, then its solution will be c a u1 plus, sorry, a u1 plus b u2 equal to 0. That is also a solution. This is called convergence, superimposing, sup, 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 sup. Okay, I'll talk about it. Superimposing two solutions. If I have a differential equation for which, and that differential equation is linear homogeneous equation, d of u by x square xy whatever equal to 0, then it is homogeneous equation. Whatever differential equation I have in u, I can rewrite as lu, where L is differential operator, d by dx plus d by dy, or d2 by dx square, d2 by dx dy, d2 by dy square, whatever. If I place u against it and it works, it comes to the same thing, then it is a linear differential. Okay, we'll go to Fibonacci series again. Now we have fx by fx minus 1 equal to 1 plus fx minus 2 by fx minus 1. Okay, in that manner, consider fx by fx minus 1. I can rewrite as dfx by dfx minus 1 equal to 1 plus dfx2 by dfx minus 1. I can rewrite as dfx by dfx minus 1, dfx by dfx minus 1 equal to 1 plus 1 by dfx minus 1 by dfx minus 2. Makes sense? And both are same. Dfx by dfx minus 1 and dfx minus 1 by dfx minus 2. If x is very big, then this can be taken as same because they are through same formula, fx equal to fx minus 1 plus fx minus 2. More or less, they will be same. So I can consider dfx by dfx minus 1 equal to L. Then L equal to 1 plus 1 by L. That will be L square minus L minus 1 equal to 0. L square minus L minus 1 equal to 0. Dy by dx whole square minus dy by dx minus 1 equal to 0. This is purely a linear homogeneous equation. Right hand side is 0, that's why it is homogeneous. Then can be operator that I can imagine, and that will compute this equation. Okay, for computing the telling it is linear or non-linear, we don't take the lower order equation. If I say dy by dx whole d2y by dx square plus dy by dx plus constant equal to 0, then lower order 0 and dy by dx will not take into the picture. We have L square 1. d2y by dx square can be talked as Lu. Okay, if it is not same, if it is not same, if it dfx by dx complete whole square, then it is Lu only to whole square. Lu means this is a linear differential, linear homogeneous equation. L equal to 1 plus 1 by L. L square equal to L plus 1. L square minus L minus 1 equal to 0. Anyway, what is solution to L square minus L minus 1 equal to 0? This is pure quadratic equation. And for that equation will be, if I have ax square plus bx plus c, then solution will be minus b plus minus square root of 4ac minus b square minus 4ac by 2a. I believe we will proceed on this. How to calculate the Fibonacci number, Fibonacci algebraic equation. This is a very mind-blowing equation. Someone can compute. I believe, I believe we will proceed on this. How to calculate the Fibonacci series algebraic equation? We will proceed on this. This explanation and this kind of this proof probably it is not available anywhere. Okay, please don't mind supporting us. +91 is the India country code 9483160610 is the telephone. +91 is the India country code 9483160610 is the telephone.